Today we're going to take a look at a Micro DPU unit by Methode Electronics. What is Micro DPU? Well, Micro DPU is your ISP's way of getting fiber optic into your apartment or suite when there's no way to actually get the fiber there. It's done by transporting it at extremely high speeds over a standard twisted pair or coaxial cable. How fast? Up to 2.5 gigabits. Today we're going to talk about technology, and one technology that I have to deal with at work. This is called Micro DPU, and I've got the hardware here. We're going to take a look at it, and this one's marked NFG because I spent a while today trying to figure out why things weren't working, only to find out that a new piece of equipment that was made in USA, by the way, and relatively new too. Is it January 11th, 23, or is it the 1st of the 11th month? So it might be January 1st. Depending on how they code it. Anyway, it's new. This was brand new in box, out of box failure. We'll take this thing. We'll take this thing apart. Micro DPU. For those of you who are not aware, and I've just looked it up here, just so I've got all the facts here. It's that you can have data rates up to 2 gigabits over twisted pair or coax. And basically, what it does is it allows your provider, your internet provider, the phone company or the cable company or whatever, to deliver fiber optics to your premise without actually having to bring the fiber optics into the premise. Now, this is mainly now used in multifamily units, apartments, for example, where it's too costly to bring fiber up every floor to each individual unit. And that has been done. We've done that for years using Invisalite, where they run the fiber down the hall and drill a hole over the door, and we wrap it around the apartment and glue it down and put the ONT or ONU inside the unit itself. That's pretty standard practice. This, however, allows us to do this on a much faster, much less expensive operation to do it, because what it allows us to do is it allows us to use the existing copper wiring that's in the building. And this would be valid in a house too. If you've got a house that is not set up for fiber, like it would have been perfect in my installation, because when I did my fiber installation, I spent about 4.5 hours just getting the fiber in. I had to take it from the demarc on the side of my house. I had to run it up into the soffit, and I had to take it all the way down to the back of the garage and around the side, and then down and in behind the siding, all the way around the rest of the house, all the way to the back, so that I could get up into the attic space and then into a fresh air vent, bring it through the fresh air vent into my furnace closet, which is across the hallway from my equipment closet, and then a hole above the drywall into the joist space, and across the hall into my closet for where my ONT lives. That was a lot of work. It would have been a hell of a lot simpler to just pop a hole through the wall in my garage, bring a telephone line in, and or just a twisted pair, cat fiber, whatever, but bring in a single pair and bring in a fiber. And then I could have used this equipment had it been available at the time, but we had not deployed it yet. So it would have allowed me to bring fiber speeds into my existing closet over the existing wiring that was there without having to run 150 feet of fiber all the way around the house just to get it back into the middle of the house, because my equipment's in the middle. It sits in the middle of the house. Anyway, this is the technology, and it can be fed up. It can be fed over coax or over telephone line or over Cat5, any three. And I've got the equipment here for a little show and tell of this equipment. We'll take a look at it and a basic setup. Obviously, I'm not going to do a full setup because I don't have working equipment here, but we'll talk about how this stuff works, and I'll show you guys the inside of some of this equipment, because I borrowed a few pieces from work, including a modem that is actually not one that we actually use. This is an old one, but it has the SFP cage. So for demonstration purposes, it will be fine, because we're not going to do it anyway. It'll do 1 or 2.5 gig over Ethernet or Cat5, and 1 gig over, I believe, twisted pair. Yeah, 1 and 2.5 gig over Cat5. It uses the G.HN twisted pair coax. We service speeds up to a gigabit over existing riser cables, for example. But it's a really cool technology when it gets set up and works. And here's kind of the block diagram of what we have. If you guys can see that off of the screen off my little tablet that I got for free a few years ago. Still works. If it works, why not use it, right? So this is basically the unit itself. That's this piece right here that I'll show you guys shortly. But basically it provides the interface and power. It uses reverse power and provides power to the fiber equipment as well as the G.HN protocol, which is quite similar to how ADSL or VDSL operates. It works along the same principle, but instead of using a VDSL modem that goes all the way back to the central office or to a fiber cabinet out on a street corner, in this case it's just a short haul back to the telephone room or your point of demarc if you're in a house and you're using it in a house, like back to a garage or a shed or anywhere that the equipment can be installed. It could be installed outside, but it has to be protected because it's not waterproof, so it has to be in an enclosure. But this could in theory be installed outside and operate outside as long as it was protected. So in other words, it could be put up under I guess it probably could be put up in a soffit for that matter, or any place that it's not going to get wet. Unheated garages and telephone closets and so forth. Anyway, that's the unit. That's just basically gives you an idea of what it shows here. It can do a link speed up to 2.5 gigabits, made by Methode Electronics. Is the company that makes them. But operating temperature is minus 40 Celsius to 65 Celsius. Storage minus 40 to 85, but operating temperature is minus 40 Celsius to positive 65 Celsius, and an operating humidity of 95%. So, I mean, it can operate pretty much any place as long as it's not going to get wet. In other words, you can't put it out in the rain. But if it's shielded from the rain, you should be good to go. And this just gives some of the status lights, which we're not going to see because I'm not actually going to make the thing work, but we're going to show you what this unit is, and this one, this NFG, will take that piece apart. So these are basically the 4 units, well, that we use. There's actually 5 pieces because there's another one in here, but what we have here is we have our standard Nokia, or whatever company you're using for your GPON or XGS. In this case, we're just using it on GPON, which is Gigabit Passive Optical Network. But you have your SFP, and your SFP plugs into what they call the uplink side, just like that. And then we have the downlink side, and we have the jumper, and that's another thing. This is used when you're using reverse power. If you're not using reverse power, this unit can be actually powered up. It can be powered locally, so if you've got local power available, you can eliminate this and just plug your telephone cord into this port, and then the other end of that telephone cord plugs into another unit. So in other words, if you're locally powering it, and I gotta make sure that I mark this one as the one that's NFG because I wasted a whole bunch of time with this bad unit today. That's why it's here, because it's not going back into stock, that's for sure. This one is defective. But basically, this piece plugs into your modem, your gateway at the other end, like that. And you can either, there's 2 ways of doing this. I will show you both. How come phone cords always find their way to get tangled? But you can plug your telephone cord into here, like that. And then this all the other way to wherever you're installing your DPU unit. If you've got local power, you can plug your power in there, plug this unit into here, and plug your fiber optic into there, and this would then take your fiber optic signal, translate it onto a G.HN, which is like a very, very high-speed DSL, and send it to this unit that's plugged into the back of the modem. This is not the implementation, though, that we use, because that would require an external 14 to 18 volt power supply. What we do is we do it this way. We plug the jumper in, this is the power unit, and we have this little power brick. This goes in the premise, so this would go in the apartment, for example. The telephone cord that goes to the gateway plugs into the one marked modem, and then there's another telephone cord that would plug into the wall socket. We'll pretend for this demonstration that this cord here goes into the wall socket, and down in the telephone room the riser cable is then plugged into this one, like that. The power inserter is plugged into your standard 120 volts, and this provides 58 volts at 30 watts out the port that's marked wall socket. This is the power plus data. This one is data only. So DC power goes out into the telephone jack on the wall, feeds the power back to the DMARC, whether it be the telephone room in an apartment, or if it's in a residence, the DMARC on the side of the house, where it is brought inside the garage or someplace where it's covered, away from the exposure to rain, plugs into this unit. This unit then takes that 58 volts, which is going to be a little less now because of the losses that will occur from the telephone line run, but it would still probably be in the 50 volt or so range. We'll take that DC power, strip it, use that DC power to power up both of these modules through the connectors that are on the back of them, so it's got power to operate the G.HN and the GPON, and at that point the data is passed out the data jack, it's combined back in with the power, sent to the power brick, which of course separates the data again from the power and sends just the data out over to the unit that's plugged into the gateway, which is getting its power from the gateway. That in a nutshell is how simple this is. And I mean, we use a Cat5 line on here, and we're typically using the orange pair, which is pins 1 and 2 on this. So I'm plugging a phone cord into here. I believe 3 and 4 also are 5 and 6 are also active, but 1 and 2 are the ones that we're using. We use a Cat5 cable. We just cut it, or a Cat6 cable. We cut it. We use the orange pair and splice that onto the riser cable. But at the other end, in the customer's premise, it's just a regular telephone jack on the regular standard pins 3 and 4 on a regular standard RJ11 plug, just like that. Once it's powered up, you'll have a bunch of lights on here. You'll have a green light on here to indicate that this has got a link to the other one, and we'll have power lights on here to indicate the status. And that's what happened on this one that I was installing, was that when I powered it up, I initially got my downlink light lit up on this, and the one on the modem also lit up momentarily, and then it went dead. And I could power cycle it and it would light up momentarily, but it just kept dropping, and it turned out that it was this defective SFP. So before I scrap this thing, I figured we'll take this apart and I'll show you guys what's inside it. We'll do it for both of them. I won't be taking apart this power supply. I guess I could show you what's in here because it's got screws on it. This one's brand new, as is this, so this will be going to a customer at some point. But we'll take a look at what's inside this thing. We'll take a look at the actual power adapter, providing it's not sealed up too tight. If I can pop the screws out and it pops apart, then we can take a look inside of this unit. But otherwise we can't. But I think it probably will come apart. It's just going to be a standard switching power supply with some power filtering and data passing. This would be blocking capacitors, for example, to remove the DC from the modem side. So this unit should just open up, or is it sealed? Oh, it just opens up just like that. So there's all that's inside here, and there's actually more than I figured there would be. It's got a little heat sink on the top here, and the power transformer has got a little bit of heat sink gel on here to keep the transformer core cool, which I didn't expect to see that. 100 volt, 220 microfarad cap there, and this other one here is probably 400 volt, 120. So this thing will operate, I guess the input voltage is 100 to 240 volts input. And where is this unit made? Made in China, of course. Power supply is made in China. It's got a couple of transient filters here in case there's any high voltage discharge. They will get dissipated here. And other than that, that's the insides of this power inserter. This is the hot side over here, obviously, and this side is the DC side, the cold side. But as you can see, it does have transformers in here to pass the data through and to pass power through. So that's that. We'll throw this back together. Whoops, better make sure I put it together the right way. And then we'll take a look at the other unit as well. And next we'll look at the interface unit, the Micro DPU interface. Pop that one apart. All right, now this should just lift out like that. And actually, there's quite a bit in here as well. Oh, it's got a big reset button and some dipshit switches. We won't touch those. They're obviously preset for the company to the protocol that's going to be used. But as you can see, I got a system on chip over here. It looks like an SoC over here mounted in the back. Some good sized capacitors. I'm just curious as to where this unit might be made. Does it say? Is this American made, or is this also from China? I know that this is made in the States. This one here. And that one, as far as I know, that one's good. The other one is the one that's NFG. It was made on Saturday. It says 19-10 Saturday. Just looking to see if there's any other information on here that might be useful, such as where this thing was made. Because it doesn't say anywhere on here. Got our two SFP cans that the fiber and the G.HN, it was HN, SFP plugs into. Some big 470 microfarad caps. It's got to be the biggest surface mounted caps I think I've ever seen. Rubicon, that's good. 2200 microfarad at 25 volts. And 80 volt 100 microfarad over here, also a Rubicon. I think this unit might be made in the States. I'm just looking to see if it has any indication of where it might have been manufactured. I guess if we pop the board out, maybe it might say on the bottom side where it was manufactured. But it'd be interesting to know where this was made. I'm kind of hoping it is made domestically. When I look at it here, I'm hoping this is something that is, that is made locally. Looks like there's other points here for coax as well for different models. This is the twisted pair version, but looks like there's coax jacks over here, or places to mount coax jacks that would be used for a different model. Okay. Will this board lift out now? It will. Do we know anything about where this is made? Well, it's Methode Electronics, which we knew because I already looked that up. But they're an American company, so what I'm curious is are they actually making this in the United States, or whether this is coming from China? But I'm disappointed to see that they're not marking the board as to where they've manufactured it, which is unfortunate. Nice board. I mean, it really is a nice looking circuit board. Looks like someone's done a bodge across there. There's a jumper in place of where a chip may have been installed for some specific model. But yeah, I don't see any location where it was made, unfortunately. One thing we will tear down is this no good, no effing good SFP. As I say, I wasted a bunch of time today trying to figure out why this thing would not sync up. And it turned out that, well, it wouldn't sync up because the brand new out of the box SFP module was no good. So let's take this one apart. There's a screw in the front here, and that probably is all that's needed to pull this thing apart. And we know where these ones are made because they proudly print it right on the label, made in USA. So this should, I think, pop apart. I probably have to take this shroud off here first, this clip. That probably has to come off first, and then the thing will, the unit will pop apart, I think. Not that it really matters, because this unit here is going to go back into the recycle bin when I'm done with it, like everything else that's scrap. It's just stopping here to see what's inside it before it goes back for recycling or whatever. I guess this one probably just goes into the bin. I don't think they take these things apart and fix them when they're defective. They're not a very expensive device, so I don't think they'll be doing anything on this. Yeah, okay, that's off. Got a big heat sink pad on here on top of this chip. Pop that out of the way so we can at least see what's in here. Not much in here, just a couple chips. There's a large SoC here. I'm sure that's what that one is. It's a flat pack of some type, a BGA chip. And LED down here that lights this light pipe up. This should pop out. I would think this whole thing should just slide right out. I wonder if the Jesus clip has to come off. One Jesus clip out of here. Okay, that comes out now. I wonder if the board will slide out now with this whole connector on the end. That's what I'm thinking, is that this might push its way through, just so we can see what's on here. Ah, there we go. That's how that comes apart. And there's what's in here. That's a little tiny chips on this one. So I'm not too worried about this because this is defective, this unit. I wasted an hour on this today because, of course, when things don't work on a new installation, when things don't work, you start looking for other things like bad wiring and and bridge taps and stuff, right? You start looking at the building wiring to see why is it not working. You don't think that you're going to get an out-of-box failure of a new unit, but in that case, that's exactly what it was, because after checking everything else and spending an hour troubleshooting and not getting anywhere, I went to my truck and grabbed the new one of these. I actually grabbed two of them because I didn't know which one was bad, and I plugged this one in down in the phone room, and boom, it lit up. It's like, ah, crap, it was a bad part. So something on this is defective from right out of the box. So this one here goes back. I'll just throw this thing back together, send it back to recovery. That's why I don't want to do any damage to it. Try to get this thing apart and not damage it in any way, because I will be obviously sending it back. But that's what's inside here. It's kind of a neat little device. Not quite as cool as, oh, there's a capacitor right there, it looks like. Does that look like a cap in there? Looks like a cap that's inside there, doesn't it? Huh. Anyway, I just figured I would show you guys what that thing looks like inside. Now, if I can only get this thing back together and have it kind of resemble that how it did before it came apart, so it doesn't look like it's been taken apart. There's an LED right there. There's a little light pipe that goes over top of it that lights this whole thing up on both sides. That's how I knew it wasn't working, because this little light wouldn't light up. And it goes together like that. It goes in there just like that. And then this little heat sink compound goes on top here. Here we go. It's back together. Alright, okay, I guess that's about it for this one. We'll throw this back in its box and send it back as defective stock. Thanks for watching. We'll catch you in the next one. Hope you enjoyed this look at this piece of technology now that's rolling out across the country to bring super high-speed internet via fiber into locations where it's impossible to get the fiber right into the building or into the location.